Hi, my name is Ku Muhammad Isamuddin Bekumaso. My metric number is s51899. I am from course Bachelor of Science Computational Mathematics with honor under Faculty of Ocean Engineering Technology and Information of University Malaysia Terengganu. My supervisor is Prof. Madya Dr. Gabitasan Rodusami. My title for my final year project is Principal Component Analysis as Dimension Reduction Tool. In the last couple of many years, bounteous measures of information has poured into our life. Individual map information consistently. Information can be modeled containing lots of highlights that might be helpful over time. Measurable and machine thinking techniques experience issues when managing such hard dimensional information indices. To extricate significant highlights from the information index or to get critical data that we need, there is a way. A method are those that reduce the number of variables in a dataset. If we have more input factors, often make a predictive modeling task more complex to visualize the data. In this project, we will use the above using certain mapping methods to manipulate the data set to minimize data dimensionality. In contemporary culture, we are surrounded by a great deal of data from different age groups, digital communications, schooling, the environment, medical care, and so on. In order to analyze and forecast outcomes, we want to obtain useful knowledge from the data. However, raw data can be difficult to understand and difficult to model since we may have missing data that contains a lot of noise, or data that is extremely high in size. In order to deal with extremely high dimensional data, we want to map data to low dimensions as 2 or 3 dimensions in order to visualize it. We have two objectives, which are to investigate the underlying state of PCA and to apply PCA with manual steps and scikit-learn with a point cloud. When we do the literature search, we found that when we want to perform the PCA, we need to know eigenvalues and their eigenvectors. Eigenvalue is a special set of scalars associated with a linear system of equations. They are sometimes also known as characteristic roots, characteristic values, proper values, or random roots. Eigenvector, or the other name characteristic vector of a linear transformation, is a non-zero vector that changes at most by a scalar factor when that linear transformation is applied to it. We have some method to find eigenvalues and eigenvectors, which are the power method and Jacobi iteration. The power method is used for finding greatest eigenvalues and greatest eigenvectors, while the Jacobi iteration used for calculate all eigenvalues and eigenvectors. Next part is about the methodology. We can conclude that when we want to perform PCA, we need to follow 5 steps, which are: Step 1. Standardize the set of continuous initial variables so that each of them contributes equally to the analysis. Step 2. Compute the covariance matrix to consider how variables in the input dataset differ from the mean of each other, or in other words, want to see if there is a relationship between them. Step 3. Compute the eigenvalues and eigenvector of the covariance matrix. Step 4. Check how good did the new dimension preserve its original variability. And last step, recast the data along the PCA axis. We do 2 experiments, which are PCA by using point cloud and PCA by using any dataset. Firstly, I will present about PCA by using point cloud. We will start by loading our dataset in Python. Now we will plot by using our dataset using the famous Python module scikit-learn, and we will get like this. Okay, now we do the step 1, which is standardize the set. For the step, now we will do the step 2, compute the covariance of matrix. Step 3, compute the eigenvalues and eigenvector of the covariance matrix, and we will get like in the picture. Now we will do the step 4, which is check how good did the new dimension preserve its original variability. And total variability captured by PCA1 and PCA2 100%, so it's good. And the last step is recast the data along the PCA axis, and when we do the code, and we will get the result like in the picture I showed. Okay, now for the conclusions, principal component analysis or PCA as dimensionality reduction tool are, and for extract the implicit knowledge in dataset. We ran tests to see how well the high or original and low or reduced dimensional datasets predict each other. The dataset with decreased dimensionality by using PCA preserve the most relevant information according to the findings.